Hello, I am Krister Prestoey, and this is my presentation of the Upskill project titled Combat Controller and AI Query System for Real-Time Action Games. This project focuses on addressing a crucial skill gap in adaptive AI systems, using tools provided by Unreal Engine. Let's dive into the objectives, methodologies, and outcomes in this report. This project explores the development of AI systems that can adapt dynamically to circumstances and use the environment. By focusing on Unreal Engine's Environment Query System, or EQS, and developing a blueprint class to handle AI cohesion, which we will call Combat Controller or AI Manager. I aim to create a comprehensive framework for adaptive AI. Results align with the industry standards and are tailored to meet expectations for roles such as AI programmer or technical designer. This presentation will demonstrate how research, iterative development, practical implementation were employed to bridge the skill gap. The core objective of this project was to bridge specific skill gaps in AI design, particularly mastering the Unreal Engine's EQS and Combat Crawler systems. These tools are essential for creating that AI that adapts to player actions and environmental changes. Beyond addressing my personal skill gap, this project aligns with the needs of the gaming industry, which increasingly demands robust AI systems for immersive gameplay. Examples include roles at companies like Naughty Dog and Guerrilla Games, emphasizing the relevance of this work. Thompson 2017 and 2021, Gall in 2017 both have emphasized the importance of modular and adaptive AI systems in creating realistic and engaging NPC behaviors. In the Last of Us series, search behaviors are guided by navigation exposure maps, which generate search maps to systematically identified unexplored areas. Similarly, Gallon highlights the transition from offered to systemic AI in Uncharted 4, advocating for modular systems that enable dynamic adaptation to complex environments. These principles directly inform the design of my Search EQS, which prioritizes unsearched areas using precision history, and my Cover and Attack EQS, which evaluates proximity, visibility, and safety to determine tactical positioning. By aligning with industry best practices, these EQS systems exemplify scalable, context-aware behaviors, reinforcing the academic and professional relevance of my project. Let's break down the objectives and aims of this project. The primary objectives were to implement EQS for spatial decision making and develop a combat controller to coordinate AI behaviors. To showcase these features, it would be supported by modular behavior trees for adaptive states, a perception system to switch between these states, and a shooting system to visualize the effectiveness of the key features like EQS and Combat Controller. The ultimate aim was to not only address technical gaps but also align the project outcomes with industry expectations, ensuring a strong portfolio piece for future roles. The key deliverables for this project include an attack behavior using EQS for tactical positioning during combat, a take cover feature, and a strong shooting element. A search pattern behavior using the EQS and behavior tasks. A blueprint class to coordinate and distribute roles among instance AIs and variable to change flanking directions. A robust behavior tree with states that indicate what transition the AI is in from dead, combat, hunting, investigating, searching, patrolling, guarding, and roaming. A perception system to escalate and de-escalate states based on AI senses. A shooting system that can visualize the effectiveness of the EQS. Stretch goals include AI coordinated behaviors with AI manager and group context maneuvers during combat and out of combat. This project followed a structured research and development workflow. First, I conducted a literature review, analyzing the industry practices and Unreal documentation. For project management, I made an agile framework to run the development backed by my research to run iterative sprints of design, development, testing, and refinement. I made a weekly plan to ensure the project would finish before the deadline. I made a Moscow to ensure that I had minimal requirements to finish before embellishing the project with other deliverable items. Trello was used as a Kanban to list items that needed tracking to help quantify where I was in development of the project. For developing the different deliverables, I used a practical based research method to iterate and reiterate these items and refine them as a finished product. I wrote down where things went wrong and how I fixed them. The results of this project were highly rewarding. I learned a lot about using the EQS and how the scoring and filtering tests worked. This helped me to make 2 EQS items for the shooting game. The first key item of making the AI choose dynamical cover spots with the EQS for engaging in ranged combat turned out great. It ended up with a modular component that lets the AI position in 3 different behavior of defending in blue, attacking in red, and flanking in green. Red and green can be seen having opposite flanking directions. The second key item of making AI search dynamically and systematically for player with the use of EQS turned out excellent. The AI uses a position cache to look areas unexplored with the current array of 7 positions. The third key item of making an AI manager that would handle roles in changing the flanking and attacking lateral directions turned out mediocre. It simply counted and redistributed the roles among the instance AI and changed direction based on timed events. The supporting items of behavior tree and perception system to control states and behaviors of the AI and a shooting system to showcase the effectiveness of the whole system turned out great. The behavior trees had a smooth and logical tasks executed. The perception system had a realistic and intuitive escalation in states based on a perceived sense cues. And the shooting system had a realistic accuracy and timing of shots that avoided unnecessary shooting into obstacles and friendly fire. I went overboard with the perception system, opting for 6 different sight sense variables. How illuminated the character was by 6 line traces from light source onto different skeletal mesh components on the player. Velocity and stand check, 6 different line traces from AI to player's different skeletal mesh components. Distance and control rotation dot product clamped by the vision cone, all weighted against each other to achieve a realistic or sufficient product. It had a lot of optimization and fixes to help achieve the intended goal. The shooting system was at first just a simple line trace. I went ahead and made a projectile system that included an under fire condition with a sphere overlap and bullet shot by the player. To make the animations work with the shooting directions, I had to make a separate blueprint for aiming. The blueprint needed to be predictive of the projectile path and intended destination, so I went ahead and weighted distance with the height for projectile drop and velocity for player location prediction. I also implemented debugging features to help with the development and bug protection. The behavior trees were simple enough, and created some passive states and some active states in order to make the AI always seem busy and engaged. 3 different passive states, checked between the roles of attack, defender, and flanker. The active states included combat, hunting, for chasing down last known location, investigations to clear suspicious sightings or sounds, searching to look for the player. Both hunting and investigation has a sequence that finishes with a de-escalating the behavior to a search state. The search state, similarly, has a sequence that transitions the state to a passive state that checks for AI role for the passive state. Every project comes with its challenges. The first problem were finding the research and tutorials that complemented what I was trying to achieve. Second problem was creating the search system, as I couldn't find any documentation on making it, only principles to guide my thinking and development. Third problem was tweaking and iterating on bugs and problems throughout the development. If I was to do this again, I would have started documenting all my steps more thoroughly, so that my report would be faster developed, and I would have stopped once I had a working prototype. Development went too far, and had too many features for this project to showcase its value. This project helped me learn and reach my intended targets, that will prepare me for taking on AI game design challenges at an industry level. Looking ahead, the systems developed in this project have significant potential for expansion. For example, I would have planned to explore advanced AI roles, such as defenders and scouts, and introduce AI communication for coordinated strategies and other group strategies. These enhancements would be applicable not only to combat games but also to other genres, such as stealth and role-playing games. Finally, I'd like to acknowledge the resources and inspirations behind this project. Key references include industry talks, YouTube analysis, Unreal Engine documentation, and other tutorials, which provided detailed guidance on EQS implementation and AI design. These sources were instrumental in shaping the outcomes of this work. Thank you for your attention. If you have any questions or would like to discuss this project further, please feel free to reach out via email or LinkedIn. I'll be happy to provide additional insights or discuss potential applications of these systems. Thank you.